Okay, so before I look at part for day 13, there is something I wanted to change. And that is the way we do this here. We're calling new on each one of these guys, and each one of these guys is reading the file in. And so I don't want to do that. I want to actually have run solution read in the file, because I don't want to read in all the files and parse them and whatnot, and then only pick one to run. There's no reason to do that. So run solution should call a load or a parse. Which I guess could return true or false, depending on whether the parsing worked. But we're going to assume the parsing always works. And now what we can do is we can measure it. Let start is instant now. Solution dot parse, and then let parse time equal to start elapsed. And now I have this hard-coded thing here for print solution. So maybe I just create a print time. Println can we just do as millis here? I think so. And then we can just do this point. I'm going to go colon 3 here and then colon 03 here for the milliseconds parsing. And just do that. And then we can say parse time divided by 1,000, sorry, and parse time mod 1,000. Right? Lana Spark says, are you missing one of the colons between instant and now? I am. Thank you. I do that all the time. I do that all the time. I don't know why. I can't do it. Double tap on the colons. Okay, so now this becomes, so we're going to have to change every single one of these guys now. So we are going to have to initialize it. So this is just vec new. And then this goes in here where we say fn parse. It's got to be mutable self, right? And then just say self data equals this. Right? Right, and types differ in mutability because I did that wrong. This needs to be mute self. Let's do this in the right order. So we have name, then parse, and then that. All right. So yeah, we're going to have to do each one of these. So this is going to be parse. Okay, and 12, which is the one we just did. Value. Ooh. How do we create an object with a value in it and not... I guess I could do this. This is a little sloppy, but it works. Then parse itself. Self.value is equal to sum this. And then here is just value none. And then down here, we just have to unwrap it. It's a little sloppy, but it should work. I guess it doesn't. Move occurs because self value has a type option value. Yeah, but that's why do I have to do it like this? Nope. All right, well, that's annoying. I just want to get a reference to, oh, you can't get a reference to the value inside, right? Can you? Rust reference to option. Borrow a reference to what's inside an option T. Is that possible to do? You could use match. Data as ref. Okay or nope. I mean, I could try that. What does as ref return? Let's find out. Let x equals self value as ref. Option value, and then I can say unwrap, right? And that gives me the reference to value. Okay. Yeah, okay, that works. So, oops, as ref. Okay. All the tests still pass, but the tests don't use, all right, let's see if the numbers, yeah, the numbers look the same. Where's day 12? Yeah, 754, 402. Yep, okay. All right, so I think that's a little bit better. Git status, what's the diff? Yeah. Git commit, it's just changes, right? Git commit -am only parse files when running a given solution. Actually, cargo run. I didn't look. Yeah, so now we can see how long it takes to do the parsing. Cargo run release all. We can see which day takes the longest to parse. Although they're all going to be pretty quick, right? Yeah, especially in release mode, which is the only way I'm going to run it if I'm going to include day 4, because day 4 takes like 15 seconds to run in debug mode. Yeah, the parsing goes pretty quick. Oh, I have a dot here instead of. Yeah, let me change the S to a dot. Because I think that makes more sense, right? How does that look? I didn't run them all. That's fine. Okay, yeah, that looks good. And then git add source, git commit, amend, no edit, show. Here's main with our new parse. Here's the parser, and then we change the S to a dot. Okay, good. All right. How much time do I have? I have 20 minutes. You think I can do day 13 in 20 minutes? I very much doubt it. Epic Blog says, I wrote a script around Git, which runs cargo test and cargo Clippy before allowing me to commit. That's when I realized how often I want to commit code and I know it's broken. Oh, yeah. There's a, in your Git directory, right? I did this for something else, the hooks. Yeah, they have all the samples in here, but there was another project I did where I had a hook. Blog OS. Was it in that one? Git. No, star/.git/hooks. Was it pre-commit? Yeah, so in kiloed and locks bytecode. We can take a look at one of those guys. Yeah, so I did a cargo format, cargo Clippy, and a cargo test before each commit. And I think the only gotcha on this one is this doesn't go into your repo, these files. So modifying it isn't going to, I copy this to AOC lib, git hooks. Yeah, and now it's going to blow up everything. You know what I haven't been doing is all of the Clippy stuff. So let's check Clippy. Maybe that would be a good way to clean up and finish up the, well, 24 errors and 12 warnings. Using clone as a double reference, a whole bunch of those. Expression creates a reference which is immediately dereferenced. That's in permute, so we can clean up permute. All right, let's do this. Let's finish today's stream by cleaning up Clippy and seeing what we got here. So starting from the top, this file here, 112. Oh, right. I don't think we need to do these. If I remember correctly, we had this whole issue with cloning because we were borrowing mutably and immutably. But we changed this code to use a ref cell for values. So we no longer need to worry about cloning. We might be... Epic Blog says, Clippy can be kind of a jerk. Yeah, but I like it because it's teaching me stuff. I think we can just delete those, right? Let me see if this... Yeah, 117. Yeah, so I think we can just delete all these clones. And we might be able to just do that also. Let's see what happens. Yeah. Now permute has issues, but let's come back to that in a bit. This says changes to just left, so we don't need ampersands here either. Okay, and we're still in AOC day 7. 142, we don't need to... Oh. 142, there we go. Consider removing into... Oh, what's the wrap mode? There we go. So we can just say B2 string. Okay. And then, okay, now we're in a different day. So that was day 7. Interesting. And then let's go to permute. Line 7. We don't need to pass in ampersand there. There we go. Okay, now day 10. 39. What do we got? This is one round of something. Oh, right, yeah, we're reading the numbers. I mean, Clippy really prefers this over passing in strings. Okay, 12. Line 28, this is something we just did. Change this to self-value as ref unwrap. Oh, I don't need the ampersand anymore, right? Because it's already a reference. There we go, we're getting there. And then replace the closure with just, oh, yeah, that's pretty sweet, right? For just calling the function, Rust can tell us right away what it is. Or can tell exactly what to do with it. And we can do that with the sum red list as well. On line 60. Yeah, this one here. We can't do this one because we're doing an unwrap or 0 on it. And this one, is there a way we could map unwrap against the thing? Oops, and now I blew it up. There we go. Oh, okay. There we go. I keep forgetting about this ability, although I did just use it in the partition thing. I didn't think about it for my own function. Yeah, that makes the code a little cleaner, huh? I wonder if there's another way we could do this. All right, I'm getting distracted. Git status, git commit -am Clippy Cleanup. Ooh, interesting. So this Clippy is not actually doing... Wow. And what kicked this off? What kicked this off? Was this running the tests? Oh, this is a check. How do you do a check? It's A. No. I guess there's no check here. Error, useless use of vec. It'd be nice to see that over here, right? And it's all in 07. Is it? Okay, we'll clean this up too. Although I don't have a separate thing here. Let's see if I can do this. Cargo check. Nope. So, what was it? Get hook, pre-commit. Oh, all targets. Got it. That's what it was. So this also does the test target. There we go. Okay. So 303. What do we have to do here? It's just use the slice directly. We don't need the vec. So we don't need any of those vecs. Right. Let's just see here. And I'm not breaking things. Yeah, so now we're down here. 259 is right here. 248. You can, oh, it's the same thing. They're just reformatting it, I guess. Okay, so all of these are just, all these vecs don't need to happen. Let's just delete them all. And then see what happens here. Okay, and then we have a few of these things here. 226, where we don't need the into anymore. Eight. 199. Is that it? Be nice if bacon could specify all targets as well. Bacon. So day 13 of AOC. How do we want to start this? We didn't peek at it before, did we? No. Okay, so advent of code day 13, Knights of the Dinner Table. We're looking for an optimal seating arrangement. We have the invitation, and this is invitation list, I assume. Suppose you have only 4 attendees planned, and you calculate the potential happiness as follows. So we have Alice, Bob, Carol, and David. Okay, so Alice gains 54 happiness sitting next to Bob. Bob gains 83 happiness sitting next to Alice. All right, so for 4 people, there's going to be 3 entries on each one. Carol loses 62 sitting next to Alice, but Alice loses 79 sitting next to Carol. Okay. So, oh, I see. So we're just trying to maximize what's the total change in happiness for the optimal seating arrangement of the actual guest list. Okay, so we have a test case here, and we have an answer for the test case. And so what we can do, let's get our puzzle input. Oh, I think I have this now working, right? Get input 2015 13. Did I do that? I did. Look at that. Okay, so now I'm able to actually get the input. And let's just double check here, make sure that the values are all correct. Yep. I'm just scanning a few numbers just to make sure. Okay, yeah, so that script is working fine. All right, so what we can do is just say get input greater than inputs 2015 13 text. Get status. That should just be the only thing. Get add input. Get commit -m 2015 day 13 input. Okay. Oh, right. I modified this thing so it runs all the checks and everything beforehand. Very good. So I think the first thing we want to do is just run a test case for it, right? So let's create like a constant string maybe with this data in it, and we can write a test for it, because I think all we need to do is go around each one, each not each permutation, right? Because permutations will include rotations, and we don't want to do rotations. Let me explain what I mean in case I'm not being clear. So we have this data, right? So I can say const test data. This is stir, which is, oh, not this at all, this. Okay. Oh, right. I forgot. We want to create our. This is 2015. Oops. I already got the 2015, and then day 13. Perfect. Let's move our test data somewhere else. Let's move it. Yeah, let's just put it at the bottom. That's where we need it anyway. Okay. So we have a case where we have. Let's just use this case here: Alice, Bob, Carol, and David. A, B, C, D. Makes it easy. So we can have A, B, C, D. But if we just do all the permutations would also include D, A, B, C, right? Which is just a rotation on this. So it would have effectively the same happiness total, right? Because I assume what we're going to do is we're going to look like if we're on B. We're going to look at A saying, okay, we're next to Alice, so we're going to gain 83 happiness. And we're next to Carol, so Bob then would lose 7. So Bob gains 83 sitting next to Alice and loses 7 sitting next to Carol, right? For a total of 76 happiness total. And then we go to Carol and we do, okay, I'm sitting next to Bob, so I'm going to gain 60, and I'm sitting next to David, so I'm going to gain 55, right? So we're going to go through that, and then David has to compare Carol and then the next one, which is going to be Alice, which, right, because it's a circular table. So that means that these two, and actually there's all 4, right? There's C, D, A, B, and also B, C, D, A. All these 4 have the same happiness calculation, so there's no reason to do those. The reason I'm looking at permutations because we just wrote in a previous one this permute function, which returns all the permutations of a vector of type T. As long as T supports clone, then we can create a permutation of it, right? So I should be able to do this part 1. It just print out all the permutations of A, B, C, D by saying for P in A, B, C, D. Oh, it has to be a vec, right? It's a vec type. Permutations. Println P. I might have to debug that out. Right? And that's all I need to do if I just say use AOC lib permutations. And we got an error. What's the error? Oh, missing parse. Oh, right. I have to update my Alta snips due to that. Alta. This needs a parse. Let's put a blank line here. And parse itself. That's all it is. It just needs that. And then, oh, no, it needs the full thing like that. And the other thing I want to do is change this to be create output unsolved. Like that. I don't know why some of these lines have a blue in front of them and some of them don't. Oh, I see. This is a hard tab versus spaces. Okay. Let's just change that then. That way it's all consistent. There. Okay. But what was I doing? Right. So I was just wanted to try doing the permutations, and I don't have a parse function. So let's just do parse itself. That's all we need. Data is never used. Oh, okay. We're gonna complain about that, are we? Oh. Okay. And let's just do a run. Right. So this has all the permutations. Right. We have A, B, C, D, and then we should have a B, C, D, A. Yep. And so on. C, D, A, B is here, and then D, A, B, C. Yeah. So all the rotations are there. So we want to be able to do it without rotations. And I think the way that works is that we just have to strip one off the front and then just append it back to the front for the permutation. So if we have our vector here, let v equals this thing. Come on, you can do it, right? And then we can say v iter skip one collect vec of char, right? Dot permutations. And now we can do it without rotation, except I have this wrong. What is this? It's a vec of char. Oh, it can't be built from item ampersand char. Can I do that then? Yeah. Okay, so now we have, oh, and then we have to reappend the first one, right? So this has to be our first entry, v0. And now, oh, right, and now it's not part of the array, but that's fine. We should be able to do it. So if ABCD, ACBD, and now we have all the permutations without rotations. Right, because we permuted these guys, but we've stuck an A at the front. And now we need to be able to add up the happiness for each one. So I think maybe we just create a separate function which takes an array, happiness, and calculates the happiness value for that particular permutation. In this case, we're going to use vec of strings because we have full names, right? So this goes away. And what I can do is just, I'm going to have to parse this. For now, we'll just parse the test data, which means we can finally take away the underscore. So how do we parse the test data? Let's do this first here, and then have this just print out the result. Println self data. Oh. Whatever that result is, and then we put data in here. And what are we going to do? The data is going to be Alice would lose 79 by saying this to Carol. Okay, so I think we just need a pair of names, Alice and Bob, and then how much is gained or lost. So we have to look at gain, and we have to look at lose, and we have to look at the number and the first and last name in the list. So that should be pretty straightforward, right? We're going to say instead of doing reading the input, we'll just for line in test data split n, right? Let is equal to line on dot split on space. And now we have Alice is 0. Gain is going to be 2. This is going to be 3. And then this is going to be whatever it is. Okay, so let first it's going to be array of 0. Do I care? I think what I'm going to do is I'm storing this here, right, as a hash map from a tuple of strings. Those are the names, and then the value. Let's make it I64 so we can make losing happiness be negative. And this is just data. Self is just going to return a data of hash map new. Okay. So the first is 0, array of 0. Let's take a look at the input again. Looks like that. So let so if we make happiness, negative happiness just be negative, or losing happiness be negative, we can just say sign is equal to if array of 2 equals gain, then the sign is 1, else the sign is -1. And we can just multiply the happiness value, right, which is an array of 3. Let happiness equal to array of 3, parse I32. Unwrap. And then, so that's 3, 4, 5, 6, 7, 8, 9, 10. So then let second is equal to array of 10. Like that. And then we can just insert into our data, self data insert. And we're going to put in the tuple of first last. Oh, I have to two-string them, right? First second with sign times happiness. I have to two-string these guys, otherwise it won't work, right? Because I put strings in there. Two-string. All right, let's see if that builds. Oh, I have to collect on this collect vec stir. All right. Oh, did I do the wrong thing? I64. I see. 64. There we go. And now we're not using permutations, but that's fine. We'll fix that. Oh, it did panic. Index out of bounds. Len is 1, but the index is 2. Oh, right, because I have to filter out. Okay, let's remove that line from the test data. Okay, so now we have Carol sits next to Bob, has a value of 60. So if Carol would gain 60 by sitting next to Bob. David sits next to Carol, that's 41. David sits next to Carol would gain 41. Let's see, we have a -1 here. If Alice sits next to Carol, lose 79. Okay, so I think we're parsing it correctly. That's the good news. And now we just need to walk through each one and calculate the happiness for it. All right, let's get rid of this explanation here. And we could just write a function, right, like I was going to do before, function happiness for a given permutation of people. Oh, yeah, so we'll need to also save all the people names, right? People. It's just going to be a hash set of string. Right, that way we can just say self people insert first and second. Like that. right? And then let's print that out too. Make sure that's all sane. Oh, I gotta delete this part again. Missing people. Let's put the people in. People. All right, and then hash set needs to be pulled in as well. Oh. Oh, okay. I guess we have to clone these into the hash set. That makes sense. All right, so we have Bob. Oh. Does the input have dots after it? Yes. Okay, so we have to strip the dots off. Otherwise, the names are not going to match up. We should only have 4 people in here. And we have 8. Because dotted names apparently count as separate things. Okay, so how do we strip off on the second? We can just say pop. I don't know if you can do it there. What did this end up being? It's an option char. Oh, right, we're popping that. Okay, we can say let mod second is this, and then second equals second. Or we can say second.pop, maybe? Can we do that? And that'll just pop the last character off. There we go. That works. I don't know if there's an easier way to do it, but it seems like it's a pretty straightforward way to do it. Remove well, top and end. We can actually assert that that's what we think it is. Ooh, why did that indent? Oh, because I did that. Okay. All right, so we have that. And we have these. So the next thing to do is to loop through all of the permutations, right? So that's where we were going. Let's write a happiness function. For a given permutation, v is a vec of string. Oh, this should be in our impl, right? Impl AOC 2015-13 happiness. For a particular vector of strings, we're going to look up all of the values and return a happiness result. So we'll start at 0, and now we're going to look left and right for each entry in our pair. And then we have to remember we're wrapping around, right? So if this is our seating order, Carol, David, Alice, Bob, our first one has to look at Bob and then David for Carol. And then David has to look at Carol and Alice. Alice then looks at David and Bob. And then Bob looks at Alice and then Carol. So do we want to calculate those separately? Let's... I'm trying to think now, because there is another way we could do this. If this is not... If this is vectec instead of just a straight vector, we can actually just rotate it and let Rust do the work for us. Well, let's just get it working like this for now and see what happens. So we get our first one, which is going to be Carol, which is going to check against the last one. So let last is equal to v.len. So our first one's going to look like we're comparing Carol with David and Bob. So let's result is going to be self data. Yep, self data dot get of v of 0 with v of 1 unwrap, right? So we're checking Carol and David, and then Carol next to Bob, plus self data get v of 0 sitting next to Bob, which is v of last unwrap. and then return. Yeah, then we're going to return result. So this is the first one, and then we're going to go through a for loop that skips the first one and so on. Right, because we'll say for entry in one dot dot last. Right, and then we'll add up those things, entry -1 and entry +1. Right, we can do it here. Entry, and this is entry +1, and then this is entry and entry -1. Right, and then we need to do the last one. So this is the first one, this is all the other ones, and then the last one is going to be similar to this. I could put this line and this line together, but this is in order: first, then middle, and then last. And then this is going to be Bob, which is going to be last, and last -1. And then this is last and 0. Right, and that calculates the happiness, and of course that fails because I forgot to put self in there. Expected reference found tuple. Oh, we got to put references everywhere, right? All right, we're getting closer. Oh, this needs to be mutable. Move occurs. Oh no, I don't want to move. Can I do this? Nope. Because value has type a standard string which is not implemented copy trait. I don't want to move it. I just want to use it as a... That's supremely annoying. Can we make these stirs in? Help try using a conversion method to string. Yeah, the only problem is then that each one of these needs to be two-stringed. And I can't make these strings like this, right? That'll still, yeah, expected string, found string. And I can't put, I mean, if I'm sticking ampersands in here, that's the way it's going to work. So there's no way around that. If I wanted to look these things up, I have to two-string everything. Or copy each one. Right. That's a little frustrating. So we can say 0 equals v of 0 dot clone. Let final is equal to v. Oh, final is a reserved word. Okay, let's call it v of 0, and then v of last is equal to v last clone. That gets those guys. We still need 1, and then we'll put in the loop. We can do entry +1 and -1. That's, oh, look how bad this is going to be. E is going to be v entry clone. Let prev is equal to v entry -1 clone. And let next equal to v entry +1 clone. There's got to be a better way to do this. All of this is bad. And so this is E and prev. It doesn't matter what order we do it in, right? And then E and next, because we're just summing things up. And then we have last -1, penultimate, last -1 dot clone. And then this becomes, oh, and the v1. Okay, let's see if this even builds v0, v1. Oh, and it's going to move it in here, right? So that's not going to help. v0, and v last. Yeah, value moved here, and now it's there. See? The loop should work. Oh no, it won't work because we have E in both of these cases here. I guess we can build it up. Let first is equal to v0.clone, v1.clone. Right, it's a tuple now, and then last is equal to the last.clone, last minus 1.clone. And now it's a tuple, and I can just put the tuple directly in here. First, last, right? Yeah. And now last, oh, because I renamed it. Why can't you call it final? Wrap. Let's just call it wrap. There we go. And then this becomes wrap. Warp. All right. And now these, we have to create this. Let one equals v entry clone, comma, v entry minus 1 dot clone, and 2 is that one, 1, 2. And then we have this guy here, and we have to do the same thing as this. And this is last and last, oh, wrap, minus 1. And then this is wrap and 0. And then we just change this to first, last. Okay, now it builds, and we're not calling happiness. That's why we're seeing that warning. But we can call it now. We can just figure out happiness for, and it's just self.happiness. And we're just going to pass in a vec of string, which is going to be self, people, iter, collect, vec string. Right, we just calculated on one entry, and that doesn't work. Value of type vec string can't be created from that. Wonderful. Map x xt string. There we go. And then we called it, but we didn't print it. How's that? -5. Okay, is that even right? Oh, we don't even know what we passed in. So what we need to do is permute on this vector. So let's grab this vector. Let all equals this. And then we can permute on this and print out each one, right? But that's going to print out all of them, right? And we wanted to change the way we did the permutations by doing the skip. But let's just do it this way first for entry in all. Entry, and then we can just print it. Println for entry. We get a value of that. Right? Let's see if that runs. It does not. Expected struct vec found string. Oh, because all I did was collect, right, I have to do all dot permutations. permutation iterator is not an iterator. Help removing the, okay. Oh, right, now we're borrowing this here. Can I do it this way? No. Okay, I can say print this, right? Entry. And then I can call happiness, println, like that. Get rid of that one. That'll work. There we go. Okay. So for Bob, Carol, Alice, David, we have -5. And I'm hesitating at this because we should have seen duplicates, right? Because here's Alice, Bob, Carol, David is 373. And that means Bob, Carol, David, Alice should also be the same value, but it's not. It's 245. So we have a bug somewhere. So let's just do 1 and break and see if we can get that to calculate correctly and figure out why that's not working by printing out result so far, result. Just Frylock, thank you for the follow. Much appreciated. All right. So if we can print out as we calculate it, so this is for Bob, David, Carol, Alice. That means Bob sits next to David. So we have -63. And Bob sits next to Alice. That's a gain of 83. So that should be, it says -142, but it shouldn't be -142. Oh, did I get these in the wrong order? It always has to be the same one each time, right? So, that's what I got wrong, right? We wanted to say 0 next to 1, and then 0 next to the last one. And for this guy, we want to have wrap next to wrap -1 and wrap next to 0. Okay, so that one's right. All right, let's try that one. Okay, so Alice sitting next to Carol, -79, and Alice sitting next to David is -2, and it's -81. Okay, so maybe that's correct. Okay, let's get rid of this break. Oh, and get rid of all these guys here. That's just messing up our output. And now do we have duplicates? Where's Alice? Alice, Bob, Carol, David is 330. Bob, Alice, David, Carol is also 330. That's interesting. Maybe that's a bug. But we should say Bob, Alice, Bob, Carol, David, Alice is also 330. If I remember correctly, that 330 was the correct answer. But there's a whole bunch of different ways that we can get 330. So, is there anything that's greater than 330? No. So what we can do now is, let's take a look at the input again. It was right up here, right? Oh, okay, so there's going to be a lot more permutations because we have 1, 2, 3, 4, 5, 6, 7, 8. 8 people. So the permutations are going to be much, much bigger. So that probably means it's going to take a long time. And so it would save time by not doing all the duplicates. So I think what we want to do is we want to shift this. We want to pop the last one. let last person is equal to all.pop, which means we have to make all mutable. And then we're going to permute all. We're going to permute on all, and then we're going to push on entry, which means we're going to have to clone it. The last person. And that should give us, you know what, let's leave that because that way we can test this. Let entry equals entry.clone, entry.push, last person.clone. And then we should see now a reduced number of, and of course it fails. Expected struct string found enum option. Oh, because pop is a wrap. There. Yeah, so now we only have 6 entries. And we have 2 different arrangements which add up to 330, which is fine. Okay, so I think this is working for this data anyway. And all we need to do is save the max happiness. Let max happiness is equal to 0. And then we just change this to say max happiness is equal to this dot max happiness. Right? And then we can say create output max happiness. And get rid of all this mess. And that fails. And I have to make this mutable. Okay, so we have part 1 saying 330. Oh, I'm still printing out these guys, so we can get rid of these 2 outputs. I'm still printing that. Let's try again. There we go. Now it's clean. Okay, we got 330. Okay, so now what we want to do is instead of using the test data, we're going to use real data, which means in this parser, we're going to say AOC lib read lines input 2015 day 13.text. And it panics. Unable to open file. Oh, it's without the word day. So we got 618. Let's see if that's right. Hey, that's the right answer. All right, that wasn't too bad. How long did that take to do? 40 minutes? Okay, so all right, let's commit these changes. Let's just double check with Clippy, otherwise we're going to get yelled at. Okay. Git status, git add source, git commit gem 2015 day 13 part 1. Constant is never used test data. And that's true because our test code is not I guess what I could just do is just leave it here with an underscore, right? That should allow us to do it. Yeah, that's fine. All right, good. What is part 2? Part 2. In all the commotion, you realize you forgot to seat yourself. At this point, you're pretty apathetic toward the whole thing, and your happiness wouldn't really go up or down regardless of who you sit next to. You assume everyone else would be just as ambivalent about sitting next to you too. So add yourself to the list and give all the happiness relationships that involve you a score of 0. Huh. So I think for part 2, it's just this without all the extra kerfuffle. Right? For entry in self people iter map x2 string collect vec string. Right? We don't need to pull one off and put one on now, because now we have to do all the permutations, and we can use me as the last person, or you as the last person. And then since it's a 0, it doesn't matter. Oh, we do need to, we do need to, okay. Because we have to say, okay, they're not doing anything there. What we can do then is, dang it, it's not that simple. Okay, we can extract this to be a separate function. Fn check all. Find happiest, which is I64, and this just returns max happiness, right? And then we call that here find happiest self. All right, let's get rid of that. That should still build. No, we got 6 errors. Oh, I forgot the self. And I put a semicolon there again. Oh, and this needs to be unsolved. And that's a semicolon. Okay. And if we run it, it should still say 618. Yes. Okay. So all I did was move this function out. And so now all I need to do is say people dot insert u, the string, self, and then self data insert. Oh, for every person, I need to insert a pair saying sitting next to me is 0. Or I could just say unwrap or 0 on these guys. That would be the easier way to do it. Right? That's kind of cheating, but I think that's in the spirit of Advent of Code. Especially given this, how ugly this solution is, because we're actually cloning all these things as we're searching. There has to be a better way to do this. It just has to be. Yeah, so now I can just insert a U, and then anytime it finds a U, it'll just set it to 0. So create output self find happiest. And of course that fails because I missed that. But I just, oh, I did a double create output. It's being a little expected I64. Expected reference to I64. Oh, not there. Here and here. Right? Now it's 601. Let's see if we're close. That's the right answer. All right, so that was pretty quick to do, mostly because I think I got the data structure right the first time, but it would be nice to be able to figure this out without having to clone everything. And I think the only way to do that is to store all the data in the struct and then have these reference data within the struct. And I don't feel like making that change. But if you have a string and a string and you want to look up something, I guess the only way to do that is make a copy of the string. I mean, I'm passing a reference, so it's not really moving it, but I guess it is. Yeah, so all we did was create this find happiness function and then modify these guys to use it. Um, 2015, day 13, part 2.